In episode 7 of this series, we learned how to animate a marker that moves with constant velocity. The trick is to use a loop that repeatedly calculates the amount of distance the object will move in each frame of the animation. In physics, a velocity can change when we add acceleration to the picture. Acceleration is the result of a force that causes an object's velocity to change. The higher the acceleration, the more the velocity changes. Acceleration has units of meters per second squared, which indicates how much an object's velocity changes during a given amount of time. The velocity change is equal to the acceleration times the amount of time we're considering. So, if your acceleration is 2 meters per second squared, then every 1 second your velocity is increasing by an additional 2 meters per second. Or every half a second your velocity increases by 1 meter per second. Or every quarter of a second your velocity increases by half a meter per second. Remember, we need to think about small time intervals to create our animation. We saw last time that animations are created by showing very brief images called frames. We also saw that we can calculate the distance that an object moves in each frame by multiplying the velocity in each frame times the time step. Now, with our object accelerating, this velocity is different in each frame, and we need to calculate how much the velocity changes in each frame. Here we have a modified version of our code from episode 7. We again have Nestor starting out at the origin, and we again use the move function to move him by an amount dx and dy as calculated based on his velocity. But before we can move Nestor, we need to accelerate him. We calculate the amount by which his velocity components will change based on the acceleration, just like how we calculate dx and dy. Then we use a new function called accelerate, which will change Nestor's velocity components according to the acceleration vector that we specify above. When we run the code, we see Nestor increase in speed as he moves to the right. In each frame, he takes a bigger step because his velocity is increasing. We could also give him a negative acceleration and see his velocity decrease with each step, causing his steps to become smaller. Things get even more interesting if we add an acceleration in the vertical direction. Now, both his horizontal and vertical velocity components are changing, and Nestor moves in a shape called a hyperbola. Another way that we can visualize Nestor's acceleration is by using something called a dot diagram. We can activate this dot diagram by scrolling down to where the marker is created and activating the trail type equals points option that's commented out here. Running the code with this option turned on turns Nestor's trail into a series of dots. Each of these dots is placed at equal time intervals, with the increased distance between each dot showing the increase in Nestor's velocity. You have now learned how to animate objects with constant acceleration. The activities in the description below will help you learn more about this process and show you more that you can do with these animations. Just a quick note here, I said that he moves in a hyperbola. It looks like a hyperbola to me, and based on the tests I ran, it's a hyperbola. But if it's not a hyperbola, please let me know and I will issue a correction. Thank you so much.